Okay, grade 10. So this is in the chemistry unit, how to balance equations. So atoms are not created or destroyed. During a chemical reaction, scientists know that there must be the same number of atoms on each side of the equation. To balance the chemical equation, you must add coefficients in front of chemical formulas in equations. Okay, you cannot add or change subscripts. That's the little number below. Okay, just a little bit of reminder there. So let's go through each one of these. Okay, these are the steps that you need to follow when balancing equations. The first thing you need to do, determine the number of atoms for each element. The second thing, pick an element that is not equal on both sides of the equation. Okay, and then add a coefficient, this is number 3, in front of the formula with the element and adjust your counts. Okay, so you're going to balance them out. And then step 4, continue adding coefficients to get the same number of atoms of elements on each side of the equation. Okay, so we'll do the first one together. And so what you would end up doing is you'd be given, it won't necessarily have these boxes here. These are just for the purpose of showing you where the numbers can go. Okay, but if we take a look at this, we need to count. If you go back to grade 9 and you think about counting atoms, how many atoms of magnesium are here? Okay, well, if you said 1, you'd be correct. There's nothing written here, right? And so if there's nothing written there, we just say that there is 1. Okay, so there is 1. Now, on this side of the equation, we have, and you would be doing this as well. If these weren't written here, the M and the G, you would write the M, G, and the O, okay, M, G, and O on either side of the equation. Again, it's been written here for you to help you as you are going through this, okay? So you have oxygen here. How many oxygens are there? Okay, there are 2, yes, okay. Now, if we come to this side of the equation, how many magnesiums are there and how many oxygens are there? Well, there is 1 and 1 here, okay? And so we put a 1 right here, and we put a 1 right here. Okay, now, here's our count. Now we take a look at, so we determine the number of atoms for each element. We've done that. That's step 1. Pick an element that is not equal on both sides of the equation. Which one is not equal on both sides of the equation? Well, you should be saying oxygen, right? Because oxygen has a 2 here and a 1 here. Okay. And so how could we make this oxygen on this side the same as the oxygen on this side? Remembering that when we have a coefficient, we multiply it by the subscript. Okay, so this is a 1. How could we make a 1 into a 2? Okay, well, we would put 2 here. When we put a 2 there, we have 2 times 1, which is 2. So this, if this was a piece of paper, you could just cross it out. Okay, but that now becomes a 2, and this now becomes a 2. So now this is equal, but this one is not. Okay, but it's always easier. Again, this was in the notes. It's always easier to balance elements last. You balance uh, compounds first. And so, how can we make this magnesium the same as this one? Okay, well, we press 1 times what would make this a 2, right? It would just be a 2. And so now this is a balanced equation. We've added the coefficients in front of the formula with the element and and adjusted our counts, right? We continued adding coefficients, right, to get the same number of atoms for each element on each side. Okay, continuing on then. Number 2. Again, this is going to be very similar to the last one. Actually, it's going to be almost exactly the same. Okay, we count the number of atoms, right? There's one atom here, there's two atoms there. So we put 1, we put 2. Not sure why I jumped off of that. 2. On this side, how many do we have? We have 1 and 1. 1 and 1. Okay, now what is not balanced? Okay, the oxygen again is not balanced. We have 2 on this side and 1 on this side. How do we make this oxygen into a 2? It's right now a 1, right? We put a 2. But if we do that, it may make this a 2. But because 2 times 1 on the calcium is a 2, it also makes the calcium a 2. Now this side is not balanced. But what do? We want to balance the calcium on this side. How do we make this 1 into a 2? Add a 2. Because of course it doesn't change the oxygen. The oxygen is its own element. We only change what is together here, right? This compound, we have to change everything in the compound. If it is this element, it's only changing the stuff in this element. If it's for this, it's only changing the stuff in this element. Let's move on to the next one here. Okay. N2H2 and N1H3. Okay, so let's count our numbers here. Right, so here's our 2. Here's our 3. No, sorry, that was a 2. This is a 1. And this is a 3. Okay, so now it's a little bit more tricky. Right? We can see that none of it's balanced. Okay, so where do we start? Okay, well, we should always start with the compound. Don't start with the elements. You'll end up messing something up, and then okay. And so, what can we do here? Well, we can take a look at what number could we end up turning this 3 into that would be multiple by of 2. Okay, well, we could make it into a 6. So what number would we put here? We could put number 2, right? Because if we put 2, we have 2 times 1. 2 times 1 is 2. Okay, and then 2 times 3 is 6. Okay, so now we have, okay, it's so, oh, wait a second. Now we have our nitrogen balanced. Okay, so how do we make this H into a 6? Okay, well, what is 2 times what equals 6? Right, 3. So 2 times 3 is 6. 2 times 1 is 2. There's 2 here. 2 times 3 is 6, right? So all we have left to do is to change this to a 6, and we're all balanced out. Okay, this is now a balanced equation, showing an equation as it really is. Okay, let's go through this one. Cu2. Okay, so we've got 2. We've got a 1. And we've got a 1. Okay, then here, on this side here, we have a 1. We have a 2. And we have a 1. Okay, so let's take a look at how it's balanced out. Is any of it balanced out? Well, our carbon is balanced here. And we have what is called a single displacement reaction here, okay, as far as types of reactions. But let's see what we can do to balance it out, okay? First, we've got um, a 2 here. We want to make a 2 here. Well, let's wait a second because sometimes, let's see here. Let's balance this O on this side. So if we wanted to make it the same as this on this side, we'd make this a 2, right? So if that makes that a 2, that'll also make that'll make our O a 2, but it also makes our Cu a 4. Okay, so now our C and our O are balanced, but our Cu is no longer balanced. What can we do to make it balanced? We can go to this side of the equation and we can add in, okay, what times 1 equals 4, right? Out of 4, this is now a balanced equation, okay? Okay, on this final one, we've got H2O2 yields H2O and O2, and so let's count our atoms. So um, we've got 2 here and 2 there, right? We've got 2 here. Oops. 2 here, and then there's 1 here, but you'll notice there's also 2 here. So that means that there are 3. That's 1 plus 2, which is 3. Okay, now is that balanced? Well, I mean, we have this balanced, but we don't have this balanced. So if we are going to, now, and this one can be tricky because you'll notice that only what I put here will affect this O, right? It won't affect this O. And so 2, let's put in a 2. 2 times 2, that makes this now a 4. So is it balanced on the other side? No, but that's okay. Okay, and then 2 times 1 is 2, plus 2 is 4. Okay, so we have 4 and 4 on this side. How can we turn this into into fours? Okay, that's right. Well, we add a 2, right? And so if we add a 2 here, 2 times 2 is 4, and 2 times 2 is 4. Okay, so that's the beginning of the practice over here. I'm going to get you to go through the rest of this balance, and I'll have an answer key for you. But balance each one of these equations. It'd be useful to include the list above. Okay, each one of those steps to help you to remember. Remember that you cannot add subscripts or place coefficients in the middle of a formula. Okay, and so remember, you can only add coefficients to the beginning of these right here. And what we want to do is we want to write down underneath here Na, Mg, and F. Na, Mg, and F. Okay, and then balance it accordingly.